So in a galaxy long ago and far away, I got a PhD in an arcane area called rock fracture mechanics. There ain't very many of us left in the universe. And those degrees aren't given very much anymore anywhere in the U.S. But that led me on a path of Cornell University. I've been a resident in Ithaca for 33 years, a professor at Cornell for 33 years in the Department of Civil and Environmental Engineering. And during about one half of that 33 years, I was very much engaged in what Jack described as research in the area of rock fracture, and in particular in the area of hydraulic rock fracture. So it's somewhat coincidental that after 33 years, or 32 years, or 31 years, when this all started up here, the problem came back to me. So I find myself in the unique position of being one of the few people at Cornell, and probably one of the few people in upstate New York, who has worked closely with companies whose names are now becoming on the tip of your tongue. And I know the technology of hydraulic fracturing. I know the technology of drilling. I will show you during the course of the presentation tonight some of the work that I did over those years. What is shale? How many people here are fishermen? Fisher people? Come on, admit it. 4 people? You're sick. What's the matter with people in Yates? You don't fish? All that water, you don't fish? Okay, how many people have ever walked along a marsh? Walked down a stream, walked across the river, waded in your lake. You know that bushy stuff that rises up between your toes? That mucky stuff? Yeah, that's what eventually becomes shale. It's mucky stuff. It's dead plants that have combined themselves with clay and other minerals, and over time get cooked under pressure and temperature at depth, and they become rock, shale. So there's gas there because there's carboniferous material, just like oil. And there has to have been something dead plant that got in there at some point. So it's possible when they do test borings through a rock mass, like a rock layer like Marcellus, that take cores of the rock out of the drill string, and they take those cores, they take them to a laboratory, and they assay them. What's the total organic carbon content? And if it's high, that's good. But total organic carbon content is not sufficient as an indicator of whether there's good gas. It has to have been cooked under the right pressure and temperature for the right time. So you're sitting right here. So you would be somewhere up here, and you can see that under you there's a relatively thin layer of Marcellus, and other places it's thicker. And that's out of the New York State SGEIS. That's the overall picture. And what the companies are trying to do now is make that picture a lot more detailed. And they do that using wonderfully exotic technologies, using basically all the rules of physics. They thump on the ground, they set off explosive charges, they use ground-penetrating radar, they drill holes. When they're drilling the holes, they put very sophisticated instrumentation down the hole to measure everything. Porosity, permeability, radioactivity, temperature, pressure. Smart people using advanced state-of-the-art technology. I put these comments in specifically for the Penn-Yan people. You understand Penn-Yan is an abbreviation for something? I is one. Yeah, I was born in Pennsylvania, born and raised down here, but now I'm a New Yorker and proud of it. Okay, so one might suppose that Marcellus development around Penn-Yan is not likely right now, based on what's known, because the formation is maybe too shallow. But don't bet on it, because the one great thing you can assume is going to happen in these great United States is that engineering ingenuity is going to come into play. The development of the Utica Formation. Utica is down here. It's much deeper. And the Utica was called out in the DEC SGEIS, just like the Marcellus was called out, as a target formation for development. So if you're thinking it ain't going to happen here because Marcellus is too shallow, maybe that's true, maybe it's not. Time will tell. But the Utica is not too shallow. And of course, the issue that rose up in Pulteney recently, there's always the possibility that this region, if it's judged to be not profitable for gas development, might be judged to be What word should I use? Cesspool, garbage dump. Oh, I'm showing our prejudice here, I'm sorry. It's quite possible that the large number of existing vertical wells into the Trenton Black River could be targeted as waste disposal sites. Okay, so Jack dug this up for me. These are oil and gas leases in Yates County, done between 2005 and recently. And one would wonder if it's not likely that there's going to be gas shale development in Yates County. Why all the leasing? Don't underestimate ingenuity. We have smart people in this country, and we make really good, smart engineers. A lot of my graduate students are working in the industry, and I guarantee you they're smart. Yes?
What are the color codes on that map?
Different companies. Sorry, you can't read.
So those are all leases, all
Chesapeake is pink, and I can't read it.
Gallatin is green.
Okay, so it's all the right
EOS is blue.
Okay.
Okay, now I need to answer some of the questions you asked about how far can the well go, and what was the other question I heard? What was yours?
How do you know when you're in it?
How do you know when you're in it? Okay. A pad is a location where everything happens in order to drill a well. I repeat, a pad is a location that's different than a well. There can be many wells drilled from one pad. Typically on a pad, there is initially a drilling rig to drill vertically and horizontally. To support that drilling rig, you need pumps and you need power. Pumps to pump fluids down the well under relatively high pressure. We're talking thousands of pounds per square inch of pressure. You need power, electrical power, usually supplied by diesel generators. You need a pond in which to store what's called drilling mud. That's the stuff that goes down the hole while you're drilling it, for lots of reasons we don't have time to talk about. And then you need another pond to store the water that you're going to use to inject into the well with other chemicals to do the hydraulic fracturing. And when the hydraulic fracturing is over in a well, you need a place to store the stuff that comes back up, temporarily stored. So those are the major elements of a pad. Now I'm going to show you a movie that was produced by the gas industry. You can get it online. Some of you have probably seen it. So I'm not going to take credit for it, but I am going to interrupt it periodically